Hello people, welcome to Gurukula. This is Jay. So today in this video we will see the capacity calculations of cellular system. So far in this channel we might have discussed the various multiple axis techniques such as Fdma, TDMA and then CDMA, frequency division multiple axis, time division multiple axis and code division multiple axis. So this video is to illustrate what should be the maximum capacity of users that can be incorporated in every cellular system without degrading the performance of that particular system. So that is all. So we will see the capacity calculations with respect to Fdma, TDMA and then CDMA techniques. So now without any delay we will get into the topic. So in the previous video, while we are discussing code division multiple axis, so finally we have compared what is frequency division multiple axis, time division multiple axis and code division multiple axis. So in frequency division multiple axis the users are differentiated with respect to frequency, in time division multiple axis users are differentiated with respect to time, and in code division multiple axis the users are differentiated with respect to code. And then the main advantage of the Fdma system seems to be it is better for continuous transmission and it is not suitable for the high data rate signals, because the users are restricted with the frequency band. Each and every user will be allocated with an smaller amount of frequency band, where the users are restricted to send signals only in that particular frequency band. So that is the plus and minus of Fdma systems. And in TDMA systems there is no restrictions actually for the frequency band. The user can able to send high data rate of signals since there is no restrictions on the bandwidth. The entire frequency range, the entire frequency spectrum can be utilized by the user, but the entire frequency range can be utilized only for a particular period of time. So that continuous transmission is not possible in case of TDMA systems. So that is the major difference between Fdma and then TDMA. So where the users are not allowed to utilize the system on continuous manner. So burst mode transmission is only incorporated in TDMA systems. So in order to overcome these two plus and minus from Fdma and then TDMA, we have introduced the CDMA technique, where each and every user will be allotted a different code, so that literally there will not be any restrictions on the frequency and as well as the time, so that each and every user can able to send their data by utilizing the entire frequency spectrum and as well as for the entire period of time. So this actually enables all the users in the system can able to communicate simultaneously, and as well as they can able to achieve high data rates as compared to Fdma and then TDMA systems. So now in this particular video we will be more focused on calculating what will be the capacity of Fdma, TDMA and then CDMA system. So we already know that the CDMA system will not have any theoretical limit or hard limit on the number of users which can be incorporated in CDMA technique, but still it is mandatory to restrict the number of users so as to provide an acceptable quality of service to the users. So we will see, or we will discuss the capacity of the cellular system for Fdma, TDMA and then CDMA now. So first of all we will consider the capacity of Fdma systems. So in Fdma system, the channel capacity of a radio system can be defined as the maximum number of channels or the maximum number of users that can be provided in a fixed frequency band. So that is what we call it as channel capacity. So the radio capacity is something different, where that is a parameter which actually measures the spectrum efficiency of a wireless system. So the viewers are expected to have a clear and better understanding of what channel capacity is and what radio capacity is. So when it comes to measurement, definitely we should have certain variables to measure, and then to measure the radio capacity we have two variables. One is C/I, that is channel to interference ratio, and another one is BC, that is actually known as channel bandwidth. So these two variables are widely used to measure the radio capacity. So what is radio capacity? The radio capacity is the parameter which we will use to measure the spectrum efficiency, how effectively the spectrum have been utilized or it has been used. So in a cellular system is concerned, the interference can happen at two stations, either it can happen at the base station or it can happen at the mobile station. So when we consider interference at the base station, the interference at base station is mainly caused by the mobile stations in the surrounding cells. So whatever the mobile stations that are present in the surrounding cell, the signal generated by those mobile stations will be initiating, or that will be causing the interference between the base stations. So, and this particular type of interference is what we term it as reverse channel interference. And on the other side, interference may happen at the mobile station as well. So interference at mobile stations are mainly caused by the co-channel base stations. So by this term you should have a clear understanding of this term, what is co-channel. That is nothing but two cells which uses the same frequency bands. So that is from the basics of frequency reusing concepts. So any two cells that uses the same frequency band, we call it as the co-cells. So all the cells that are using the same frequency band, that will create the problem of interference, and that interference is what we technically call it as forward channel interference. So now we are very much interested to calculate what will be the interference at the mobile station than the base station. So we will just concentrate on calculating the interference at the mobile station. So when considering the forward channel interference, the tolerable level of interference is given by a factor called a Q factor, and this Q factor is nothing but we call that as co-channel interference ratio. So the co-channel interference ratio is given by Q equals D over R, and where D is nothing but the distance between two co-channel cells and R is nothing but the cell radius. So when you consider this particular diagram, you could see that there are certain stations which uses the same frequency band B2. So this cell uses B2, and similarly this cell uses B2, and this cell uses B2, and similarly one is here and another one is over here, and all these cells whichever uses B2 as frequency, we call that as co-channels cells. So all these cells uses the same frequency band, so we call that as co-channel cells. And the distance between the co-channel cells to the desired channel, this is what our desired cell, where we are trying to measure the capacity or the interference in this particular cell. So the distance between this particular cell and the nearby base station which uses the same frequency is what we terming it as D. So the cell radius is nothing but from the center point, what will be the distance to the edges is what we call it as the cell radius. And the channel, and it is also important to note that the channel to interference ratio will not be occurred, or it will not be created from only one base station, because there will be several other cells that will cause the co-channel interference. So it is mandatory to consider all these co-channels into account to calculate the channel to interference ratio. So C by I equation will be given as D naught raised to the power minus n naught over summation of m equals k to m dk raised to the power minus nk, where n naught is nothing but the path loss exponent. You can clearly note what is this path loss exponent, which we might have seen in the free space path loss equation and two-ray propagation model. N is nothing but the path loss exponent, and where D naught is nothing but the distance from the desired base station to mobile station, and dk is nothing but the kth cell from the mobile, and nk is nothing but the path loss exponent from the kth interference base station. So actually there will not be only one base station that is interfering with the desired base station. There will be multiple base stations which is involved in calculating the channel to interference ratio. So that is why that k represents. So there might be n number of, or there might be k number of cells that is present inside the cell. So if you assume that there is the interference is caused only from the 6 neighboring cells. So if you assume that the neighboring cells is maximum limited to only 6, then the equation, the C by I equation, can be reduced to this particular form. So if you assume it is the derivation is completely based on certain assumptions. The first assumptions what you make here is, we are assuming that the interference is only from 6 neighboring cells. So if that is the case, then C by I can be reduced to D naught raised to the power minus n over 6 times D raised to the power minus n. So also we are assuming that one more parameter, that the interference will be very much higher when the user is at the edges of the cell. So interference for this particular user will be very much higher when especially when he is in the edges of the cell, because here is where there are lots of possibility of interference obtaining from this base station and as well as this base station. So interference, the probability of interference will be very much higher when the user is at the radius or the edges of the cell. So if you assume that the user is at the edges of the cell, then the distance is actually equal to r, where r is nothing but the radius of the cell. So by replacing d naught with r, then the equation will take the form 1 over 6 times r by d to the power minus n should be greater than or equal to c by I minimum. So this will be the minimum acceptable level of c by I, that is actually represented as c over I for the minimum. So from this equation, the co-channel reuse factor is given by, so we can actually rewrite the co-channel reuse factor equation, that is Q, by this. So the equation will take the form, so 6 times c by I minimum raised to the power 1 over n, and then the radio capacity of the cellular system is given by the equation m equals bt divided by n times bc, where bt is nothing but the total allocated spectrum and bc is the channel bandwidth, and where n is the number of cells in the frequency reuse pattern, where the capital N can be related to, actually there is a relationship between the capital N, that is the number of user, and as well as the Q factor. The relationship can be given as Q is equals to root of 3 times N. So when we combine all these three equations, so this is my first equation, this is my second equation, and this is my third equation. So when we combine all these three equations together, then we will get m is equals to bt over bc times q squared divided by 3, and that can be rewritten as this particular form. So this equation is what we call it as the maximum amount of the channel capacity equation for the frequency division multiple axis system. So when we note down, now coming to the capacity of TDMA system. So in practice, TDMA system improve the capacity by a factor of 3 to 6 times as compared to Fdma system, that is analog cellular systems. So interference are reduced by powerful error control mechanisms and speech coding mechanisms, and enables the better performance in higher interference environment. So in TDMA systems, we will be incorporating powerful error control mechanism and speech control mechanism so as to bring up the performance of TDMA systems. So the mobile assisted handoff allows the subscriber to monitor the neighboring base stations as well, and making the best available base stations choice. So this the special type of handover will be incorporated in the TDMA system, so that helps the TDMA system to choose the better available base station. So TDMA system also makes it possible to introduce adaptive channel allocation, and this eliminates the system planning since there is nothing to do with the frequency here in TDMA. So in TDMA, all the users are free to use the entire spectrum of the frequency, so that there is nothing to do with the frequency allocation. So dynamic allocation is possible over here. The number of TDMA channel slots that can be provided in the TDMA system is found by multiplying the number of TDMA slots per channel by the number of channels available. So which is actually mathematically represented by this particular equation, and where m represents the maximum number of TDMA user supported in the channel. So this actually compares the various systems with the various parameters over here. So this is all about the capacity, though this is how the capacity of TDMA systems can be depicted. Now when you consider the capacity of CDMA systems, the capacity of CDMA systems are interference limited, whereas in your Fdma and then TDMA systems it is bandwidth limited. So therefore any reduction in the interference will lead to increase in capacity of CDMA system, where TDMA and Fdma reuses the frequency depending upon the isolation between cells or the geographical distance, and that is not possible in CDMA, where CDMA can reuse the entire spectrum for all the cells, and this results in increased capacity of CDMA system. Considering a single channel CDMA system, the desired signal power, that is S, with n-1 interfering uses can be given as, so the signal to noise ratio is given by an expression 1 over n-1. In addition to SNR, it is also important to calculate the bit energy to noise ratio, that is EB by N0, which can be given by the expression, so W by R divided by n-1. The above equation does not consider the background thermal noise eta. So when you consider the background thermal noise, then the equation will take the form EB by N0 is equals to W by R divided by n-1 plus eta divided by S. So when you rearrange this particular equation, that will actually tell you what will be the total number of users that can access the system in such a way that n is equals to 1 plus W by R divided by EB divided by N0 minus eta divided by S. So this is an equation which we might have seen already while discussing CDMA technique, and where W by R is nothing but the processing gain, and where eta is nothing but the background thermal noise, and S is the power of each users, and N is the number of users that can be given access to the CDMA system. So this is an capacity equation for your CDMA system, and the equation is valid only for single channel CDMA systems, and when it goes for multiple cell CDMA systems, the equation will be not valid. So that will be a different equation for multi-channel CDMA systems. So in order to achieve the increase in capacity, the interference due to other users should be reduced. So how do I reduce that? There are actually two ways to reduce the interference in CDMA system. The first approach for reducing the interference is using the antenna sectorization. So based on the cellular principles, there is a concept called as antenna sectorization, cell sectorization, where actually you can go for 120 degree sectorization or 60 degree sectorization, whereas in CDMA is concerned, we can go for 120 degree sectored cell, so that we use 3 directional antennas is reduced by 1/3 of omnidirectional antenna. So this increases the capacity by a factor of 3. So instead of using one antenna, one omnidirectional antenna, you can use 3 directional antennas by the concept of cell sectorization, so that every antenna is reduced by the capacity of 1/3. The second technique that is used to reduce the interference is monitoring the voice activity such that each antenna is turned off during the period of silence. When a particular user is on call and he is not at all listening, if he is not at all talking, then the power levels to that particular user can be brought down, or in other words, I can turn it off during the periods of silence. So when no voice activity is the voice activity is denoted by the term called alpha, and this mode of operation is referred to as discontinuous transmission mode, that is DTX. So we will try to keep the system at low power whenever there is no signal transmitted. Say for an example, on a practical situation, when one user is talking on the call, the other user is obviously listening, so that the effective utilization of the entire channel allotted between these two users is only 50%. So that instead of allocating 100% of channel for each and every user, we can restrict. So if user A starts talking, then we can restrict the power that is allocated for user B, and vice versa. The same can be done when user B is talking and user A is listening. So we can reduce the power of the user whomsoever is listening on a particular communication. So by this, the effective power can be achieved. And this making this system on and off will lead you to a special type of transmission. We call that as discontinuous transmission mode. So therefore, after considering the no voice activity system, the EB by N0 will take the form like this, and you can notice that there is an additional parameter added over here, alpha, where alpha is nothing but the voice activity. So depending upon the voice activity, the bit error rate or the bit rate can be bit energy rate can be varied. within a particular sector. So where alpha is the voice activity, ns is the number of users per sector, EB by n naught is nothing but the bit energy to noise ratio, that is within a sector. So that is the difference what this prime denotes. Generally this will be denoted by EB by n naught, where EB by n naught dash represents the same bit energy to noise ratio, but this is within a sector. So it is also important to note that the power control of CDMA system also contribute in controlling the interference among the users present in the system. So power control systems are also equally important to note down in improving the capacity of the system and also to improve the performance of the system. So when there are more number of users, then the system becomes interference limited rather than noise limited. So then the number of users can be represented in the system is given by ns is equals 1 plus 1 by alpha times w by r divided by eb by n naught dash. So this will be the final equation which actually defines the number of users that can be effectively incorporated into the system, and this can be treated as the capacity equation for CDMA system. So just to sum up, so this video we might have discussed the capacity of Fdma, TDMA and then CDMA. So see you in the next video. Until then, happy learning.